This is the Discovery Files podcast from the U.S. National Science Foundation. From advanced artificial intelligence systems to complex quantum computing and breakthroughs in nanoscale components, technological advances are rapidly changing our daily reality. While we cannot predict the future of work, the economy, or society in general, we do know that to maintain leadership in science and technology discovery, we must create an approach to science, technology, engineering, and math education that inspires the next generation and prepares the U.S. for the future. We are joined by Michele Yatchmeneff, Associate Professor of Civil Engineering and Executive Director for Alaska Native Education and Outreach at the University of Alaska Anchorage, who has spent her career working to prepare and engage the communities around her to move towards a successful career in the STEM fields. Professor Yatchmeneff, thank you for joining us today.
Thank you for having me.
I'd like to start with a little bit of background, and I want to know when or how you knew you wanted to pursue a career in STEM.
I knew from a young age. I had been in middle school and they had professionals coming in to talk to us, and they were talking about needing math and science and how well they were doing in their lives, having money and having the ability to travel and do other things. One of the other things is growing up in small communities in Alaska. It was commercial fishing, it was subsistence fishing, and there was a lot of science and math involved in doing that. And that was the other thing with wanting to do STEM was I wanted to be able to help with all the things I was doing in my community, but also have a good life, have a good career. And so that was the first time was probably around middle school. And as I went along further, it was doing summer camps, looking at potentially going into the health field. And then I did a summer camp that was focused on engineering. From there, I knew I really wanted to focus on engineering.
What about engineering caught your interest specifically?
The main thing about engineering was that it combined both math and science. I was really good at both, and it was hands-on. I could actually think about a design or think about a solution and actually get to implement that. And that was whether it was electrical components, whether it was looking at water, it was always something that you could think about and then actually implement.
Moving into your work a little bit, I will confess I read your dissertation and I got interested in the historic education system there a little bit. And so I wanted to ask you about some of the limitations and challenges in the educational system in Alaska over the last 100 years or 150 years.
There's a few, and being part of that system and then having parents and grandparents part of that system, each level it got a little bit better, but for example, my family was dealing with, my parents were both able to do high school, but they had to move communities. They had to move in order to be able to take those classes and have a family support system that was willing to let them do that. They could have stayed in their home villages and not pursued school, but because their family knew that that was important, they actually moved their whole family over to another community so that they can actually have education. And that's all across the state. If you stay in your home community, you might be able to get some of that education, but higher quality education, you might have to move far away and be far away from your family. My parents actually moved us from their communities in the Aleutians to actually be in Anchorage, which is the biggest population here in Alaska. And they knew that that was important because they wanted their children to have the ability to be able to go to high school, have college experiences, have summer camp experiences. And that's how it is across the state. Being able to willing to send your children, people special to you, away in order to be able to experience some of those important things to get, that career visioning or those things around career professional development. Another thing is historically, schools were not provided in communities. And today, if you have not enough students, the state won't help you in providing education to students. And so we have teachers that cycle in and out. They're not from the state of Alaska. They're from outside usually. They don't understand, how it is to live in rural communities. So they get there, they have a challenging time. They don't spend much time with the students and then they leave. And the students see that. The students see that their teachers are not wanting to live in the community, are not wanting to get to know the students. And that's detrimental to them. They don't feel that they belong in a school setting when they have their teachers come in and come out so frequently. And a lot of the teachers don't have that high-level math and science background to be able to introduce students to that and have them be encouraged to consider STEM as a career pathway. And so because of that, we've had to find other ways to get that kind of professional career development and also other ways to bring that to the student. And so it's coming to the University of Alaska, the Alaska Native Science and Engineering program, in order to be able to provide those kinds of opportunities for our students here in Alaska.
I don't think people have an idea of how the population is in Alaska, like how rural some of it can be, or how big the scale of the state is really.
The state of Alaska is huge. If you overlay the state of Alaska over the top of the United States, it touches one coast to the other, the top of the country to the bottom of the country. So it's very spread out. My community has about 1,000 people that live there. One of them, King Cove, has about 1,000 people. If you go over to Falls Pass, it has less than 100 people that live there. And so they're very small communities oftentimes. A majority of the state, half of it lives in Anchorage, which is our largest city. And then we have hub communities spread out through the state, Nome, Kotzebue, Bethel. But oftentimes you have to either fly in or boat into those communities. Boating in is usually rare, so it can be very dangerous in terms of weather and then also very expensive to fly. For me to fly home, it's $800, and that's round trip. And it doesn't seem like I'm flying very far, but it's just very expensive and then oftentimes very dangerous.
Okay, so moving into the educational opportunities, I know there's a program called ANCEP that you were both involved with as a student and professionally later on. And I wanted to ask you, what is ANCEP and how does it give people opportunity?
So the Alaska Native Science and Engineering program, or ANCEP, started in 1995 with one Alaska Native student. It was started by Dr. Herbert Schroeder Ilisari. It's his native name that he got given, which meant teacher. He actually was working in engineering. He was doing water, wastewater, and he never came across a Native engineer working in the field. And, the engineers were all working on projects that would have large impacts in water and wastewater in their communities. And they couldn't speak to each other sometimes. They're trying to solve these water, wastewater problems, and there's no engineers there that are from the community that can really speak to, what should the solution look like. So he started up as a professor. He realized there needed to be engineering people in communities being able to help solve the problems in their communities. And so he started working with Native students, and he grew the program. When I was a student, it was mainly a scholarship program with the help of NSF, with the help of LSAMP, LSAMP. We got scholarships to go to school, and we were able to get our engineering degrees. I started in college. I was pursuing my engineering degree. I had transferred schools a few times. And what I was seeing was less people that looked like me as I was getting further along. And I started to feel like I didn't belong. And then when I come back to the University of Alaska Anchorage, I joined ANCEP and realized there's people that were like me, that were trying to go into engineering to help solve problems in our Native community, and realized I came home to find home. And it was amazing to have other students that were like me that I could study every day with and form a community, and still form a community with them. As I graduated, I went on to do water, wastewater. But as I was going through getting more advanced, I would run into them. I would get to weddings. And so amazing to have a community when I was a student, but also following being a student. And we did an alumni association and actually get together annually.
Right. Keep that little touchstone of community going.
Yeah. And so when I started, we were a scholarship program and then a Sunbridge program, again, with the help of NSF's LSAMP. And when I came back in 2007 to be that program, now today there's about 3,000 students across the state of Alaska doing programs from kindergarten all the way to the PhD. And involved component for each level of school. So whether it's K through 6 and then 6 through 8, middle school, and then up through high school, all the way to undergrad and graduate school. And one of the main things is I tell people is, it's great in pre-college to have an inspirational piece. The other part of it was knowing that you have to take math and science courses, and not just knowing that you have to take it, but also getting those teachers or connecting you to programs. And then once students are in middle school, again, requiring that they complete algebra 2, completing chemistry, physics, all those things when you're a high school student, and actually doing college courses at the same time. And so students who are joining that are being able to graduate with BS degrees in about 5 years, from 9th grade all the way to getting their BS. They're doing that in 5 years now, rather than 8 to 10 years that it typically takes. And then the other thing that they help me with is actually go on to get my PhD, continue on and do that pathway. And it's not a fun thing being the first and only of anything, but what keeps, I think, I and my colleagues going is knowing that we won't be the first and only for long. We're helping students.
And it sets up one of the research questions I wanted to ask you about being a role model. How important is it to have a role model for engaging students in STEM?
To me, having a role model is so important. Having people that look like you is significant. When I was a student, there wasn't a lot of people that looked like me in terms of faculty, but there was a lot of people that looked like me in terms of my fellow students, and then also staff. There was multiple staff that were working, that were our advisors. Tracy Mueller was one of the earliest ANSEP people, and now she was our advisor, but she looked like me. She was a businesswoman, she was Alaska Native, and that really helped me see myself becoming a professional and becoming a career woman. And so what I know is that having someone that looks like you is very important. I know there's research around this, that it helps to create that pathway. Being the first and only in a lot of areas in terms of being Alaska Native and a PhD in engineering, that I will help, my fellow students that are coming behind me, hopefully make that journey easier for them. It's never been my goal to have anyone emulate me. It's just knowing that I'm making that pathway much easier for them is what motivates me in my job, what helps me realize what I'm doing is super important, because I don't ever want a student to feel like I did, where they didn't see themselves, but also didn't feel like they belonged. Having that belongingness is so important when you're pursuing any career, let alone a very challenging and difficult career, is that helping them is what's helped me project me in my career.
In your research, you also looked into the importance of relatedness. And I wanted to ask you about the distinction, I guess, between that and role models in engaging students in STEM.
The theory that I looked at was self-determination theory, and there was autonomy, competence, and relatedness. And a lot of the research was talking about, that the main important thing was autonomy and competence, believing in yourself, but also having guidance to get there. But what my research showed was, for Alaska Native students considering STEM, is that they needed to feel like they belonged. They needed that relatedness piece. And so, I think my research helped advance that theory that different kinds of students need different kinds of focuses. And Alaska Native students needed that belongingness piece. They needed to feel like there was a home for them on the campus. They needed to feel like there were people supporting them. And what the students said is that having a space, so the Alaska Native Science and Engineering program has a building on the campus, and today they actually have 3 buildings on the University of Alaska campus, one for middle school students and pre-college students, another for high school students, and then for another building that looks like a canoe is actually for graduate and undergrad students. And so they said, I have a home here. This is a place that I can call my own. And so that was the biggest thing for them, is that belongingness was really important, and seeing students like themselves, and then also seeing faculty and staff like themselves was extremely important to them.
So I want to ask you about your career award. What difference has NSF support made to you professionally?
So, I got an NSF Career Award, and it was focused on Alaskan Native students. And it was the first and only for the 5 years that I had that award, NSF Career Award at the University of Alaska Anchorage. I don't think that immediately the College of Engineering saw it as important. And I hate to say that, but it was, I think, because it said Alaskan Native in the title, maybe people didn't think it was real research, and it was. It was very important research to the university, to me, to our Alaskan Native students. It was challenging at first to say that I was the first and only at the university for that length of time. And I think it also changed minds. It helped people see that NSF supports this kind of research. NSF values this kind of research, and it helped move the needle for Alaskan Native researchers and Alaskan Native people, that this research was focused on Alaskan Native students. And my research helped me in my career because it actually supported me to do qualitative research, working with Alaskan Native high school students, to have them tell me what helps you feel like you belong in your math and science classrooms while you're a high school student. And I think it also helps other people. It helps other minoritized students in STEM realize that not only providing the classes is what we should be doing for students, we actually have to work on helping our students feel like they belong in those classrooms. And consider that as part of our teaching method as we're moving forward, as we're moving students forward, is that what's important to them is going to help them succeed. So we need to focus on that. And so to me, that was amazing that NSF supported that, but also seeing what our students need to be successful is also extremely important.
You mentioned moving the needle forward, and you've moved into more of an administrative role, to my understanding, at this point. And I wanted to ask you about what success looks like in that role for you.
I've moved into being an administrator at the University of Alaska Anchorage. I'm the Alaska Native Education and Outreach Executive Director. This is an inaugural position. Previous to this, we did have an Associate Vice Chancellor who was working on Alaska Native success, but this is actually now within the Chancellor's cabinet. Being a new position at this level means that the university is supporting Alaska Native success at all levels. And what does success look like in that area? To me, that it's sustainable, meaning it can't be, if my position goes away, that we'll remove having active people working on Alaska Native success, that we're actually incorporating Alaska Native success into everything that we're doing. That to me is what success looks like. We're always going to have ups and downs. We're always going to learn something new from some of the activities that we're doing, and maybe charge a new pathway from those things. But it's important that we're all working on it. And I think that's what is extremely important, is that, my position goes away, that it doesn't mean we're not focused on this. It just means it's incorporated better. So to be honest, success might mean someday my position will go away because we've incorporated it at all levels. We don't need this position. We're doing it on our own without having me help some people be accountable to doing and working on Alaska Native success.
I want to finish up by asking you about the next steps. Like, what would you like to see in the development of the program over the next few years?
So next steps for me is having more Alaska Native scientists and engineers being faculty. I was actually at a conference recently, and I got to bring a new faculty member who is Alaska Native. And so he's the fourth Alaska Native in the world with a PhD in engineering. There's only 4 of us, and he's one of them. And I got to bring him to a conference and start working on his research pathways with him. And it was amazing because, I didn't have necessarily an Alaska Native person to be able to do that with me when I was in that pathway, but being able to do that for him has been phenomenal. And being the next steps for me is not just continuing my research, but hopefully having multiple people doing, Alaska Native, Arctic research, engineering research, science research that has big impacts on the Arctic and our Alaska Native communities. And so I'm just super excited to be able to be a mentor and help him in his pathway. But I see him doing the same thing for the next generation, him being able to do that for students coming up behind us.
Special thanks to Michele Yatchmeneff. For the Discovery Files, I'm Nate Potker. You can watch video versions of these conversations on our YouTube channel by searching at NSF Science. Please subscribe wherever you get podcasts, and if you like our program, share with a friend and consider leaving a review. Discover how the U.S. National Science Foundation is advancing research at nsf.gov.